Hello everyone, welcome to this tutorial video of the hydrogen superstructure framework. The framework is designed to evaluate the environmental impacts of hydrogen energy systems, including hydrogen production, storage, and applications. Also, the framework optimizes the configurations of hydrogen supply chain to achieve the minimal environmental impact. To operate this framework, a few files are necessary. First of all, the code. On GitHub, there are 5 Python files in total, including H2 input, H2 LCA, H2 supply chain, MC, and utils config file. In addition, some data files are required. These include the inventory data file, scenario data file, Monte Carlo simulation data file, and geographic location file. In my case, I use the IncoEvent database, so I have the IncoEvent database geography information file here. I also provide the inventory data, scenario data, and MC template here on GitHub. Now I will show you quickly how this works and explain how to use it afterwards. Here I have a demo folder that includes inventory demo, scenario demo, MC demo, Excel file, and a results folder where all the results are stored here. So it's empty now. And I also have a results demo folder that I store some results I prepared for this video. This example shows a simple hydrogen energy system, which includes one hydrogen production pathway SMR, one storage method compression, and one application fuel cell vehicle and distribution via compression. Now I will run the H2 input file. Okay, now we get the results. The file provides a list of exchanges for users, and the users can select the best match exchange in their case. Then just copy the whole row. So let's take the electricity for example. Copy the whole row from the exchange sheet to the input sheet. So you just copy and paste every exchange. Then you're good to use the and save the Excel file. I will skip the copy and paste work here. So once you copy and paste all the exchange, you just need to copy the path of this file and paste it in the utils config Python file here, like the input file path. Then you can run the H2LC file here. I will skip the copy and paste here and use the prepared one instead. So let's just take a look at this. So it has all the exchanges, all good. Okay. Then I just need to copy the path of this file and paste it here in the utils config file. Okay, then just save it and run the H2LC file. Okay, this should take some time. This returns Excel file that includes the calculated environmental impacts for each technology per 1 kilogram of hydrogen produced, stored, and utilized, and 1 kilogram of hydrogen transported for 1 kilometer in the distribution case. Then I copy, sorry, then I copy the path of this file and paste it here. And run the H2 supply chain file. Got to save this. This file uses the input from the scenario demo file and the LCA results file. Okay, here we get the results, get the optimization results. It includes the solutions and GLP results. If you would like to do the Monte Carlo simulation, you can run the MC code. The MC code uses the MC information in the MC demo file and returns an MC results folder, which includes the bar plot of the Monte Carlo simulation results. So this is an example for running 1000 iterations. And also an MC Excel folder that includes the values for each iterations. This step may take some time for the code to run. This is a brief walkthrough of the code. Next, I will give you a little bit more details. The utils config file includes all the file paths and file name. It has 4 parts. The first part is the name and paths that need to be set up before running the code, and no change is needed during the code. It includes project database name and some results file name, an equally invented file path, location file path, the inventory and scenario information file path, and a folder path that store all the results file. The second part is the Monte Carlo simulation part, which includes MC project name, number of iterations, and MC information file path. The third part includes 2 results file paths that need to be updated after getting the results, the input file path and the LCE results file path. And the final part is a function that avoids overwriting when exporting the Excel results files. So it's basically giving each file a different name. The inventory Excel file includes scenario sheet, summary sheet, and inventory sheet for each technologies. The scenario sheet includes location information. In this example is British Columbia, Canada, and LCIA method information and impact categories. So if you want to add more impact categories, just add it in on this row. So for example, you can add acidification here, or if you want to evaluate all the impact categories for these impact methods, you can just delete the stuff, like leave this row blank. The summary sheet summarizes all the technologies. This information is for the code, so you just need to put all the hydrogen production, storage, and application technologies here. And you should make sure that the name matches the sheet name. So these are all the technologies for this example. The distribution do not need to be summarized here because it's calculated in a different way. I differentiated the hydrogen production, storage, and application using different colors. These sheets contains the detailed inventory and identifies if this inventory is biosphere exchange. So if you want to add more technology, just simply copy the sheet like this, create a copy, then before compression. Okay, they just rename this sheet and update all the inventory here. And also you need to update the summary here. Once you update all the cells, you are ready to run the H input code. The H2 input file transforms inventory data into Excel workbook, which can be used in Braille too. As I mentioned before, once you get this result, simply copy the exchanges to the input sheet and update the file path. Then you can run the H2LC file. The H2LC file calculates the environmental impacts. Once you get the results, update the file path here, and you can run the supply chain file. The H2 supply chain file optimizes the hydrogen supply chain with scenario data. For this code, you need the scenario Excel file. The scenario sheet includes the total hydrogen produced, stored, or used, distribution distance, and optimization parameter. For each technology, you need the capacity, anticipate portion or amount, and minimum amount. If you want to add more technology, just add one more column here. These are just some scenario information. You do not need to fill in every cell, but it's necessary to have at least one quantity information. This can be either the total amount of hydrogen for one stage, so like one of the 3 cells in the scenario sheet, or the specific amount of hydrogen for each technology in one stage, which is the anticipated amount in these sheets. And also, the efficiency information is required for hydrogen storage and the use. For the capacity, if there is no limit, you can either leave it blank or fill in now. With this file and the calculated LCA result file, you can run the supply chain code and get the results. Also, an additional MC Python file is provided for Monte Carlo simulations. This Excel sheet is similar to the input file we get from the H2 input code. We have an impact category sheet, a database sheet, and inventory for the assessed technologies. For the exchanges, you can simply copy and paste the same exchange in the input file and fill in other information like uncertainty type, location, scale, shape, min and max. Then update the file path and define the number of iterations, and you're ready to run the code. Okay, that's the end of the video. I hope it gives you an idea of how the superstructure framework works and how to use it. Thank you for watching.